Hello guys, today I'm just recording a video on some basic insights on how to solve questions related to the topic periodic table. I know many of you guys have this topic coming in for your exams, so I thought why not this video can help you all in order to solve these type of questions. By the way, you guys can also change the quality of the video in the YouTube settings. If you guys want to see this video more clearly and the questions more clearly, that can also happen as well. And yeah, by the way, there might be some bonus tips here and there, so do watch the whole video. And if you guys have time codes, will also be in the description box below, so that you guys can skip to any question you guys like. And if you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's begin with the video. Alright, so question 1 states that the electronic structure of the atoms of 5 elements are shown in the figure below. By the way, this subject is for chemistry, and I've used the site Physics and Maths Tutor. It's a very good site in order to solve questions related to the GCSE concepts and all. And yeah, so the letters are not the symbols of the elements. So as you guys can see, that these are not the actual elements, but they are representations of the elements. Now you have to choose the element to answer the question. That each element can be used once or more than once or not at all. You guys are going to use a periodic table. Now one bonus tip that I would like to tell you all is that in your iGCSE exams or in your GCSE exams, they usually give the periodic table so that you guys can use that and refer to answer these type of questions. So that might be also helpful. Now you have to answer that which element of this is hydrogen. Now you have to know that hydrogen in the periodic table has some value of about 1, so its atomic number is 1, and its relative atomic mass is also 1. So that means it has let's say 1 electron in its outermost shell. So you're going to look at which element has 1 electron in its outermost shell. So you can see that element B has 1 electron in its outermost shell, so we're going to tick B. Let's move on to the next question. Now the next question is asking which element is a halogen. Now a halogen is in the group number, let's say group number 7. So that means that it's going to have, let's say, 7 electrons. I think roughly about 7 electrons in outermost 7 electrons out there, so 7 electrons in outermost shell. So that's going to be about element D because it has 7 electrons in its outermost shell. Another bonus tip is that elements with similar properties, they form columns in the periodic table, and you have to know that the group number tells you the number of electrons in the outermost shell. So since we know that halogen is a group 7 element, halogens are group 7 metals, is that halogens, and they're not metals, I think. I'm not sure. By the way, so halogens are non-metals. Just to clarify that again, I know what halogens are. Is that halogens, they're non-metals, while transition metals and alkali metals, these are actual proper metals. So since halogens and noble gases are somewhat related to group 7 and group 8, they're non-metals. So halogens come under group 7, whereas noble gases come under group 8, also known as group 0. So halogens, being group 7, have 7 electrons in the outermost shell, so claiming that element D is going to be an halogen because it has 7 electrons in the outermost shell. Alright, let's move on to the next question. Now, which element is a metal in the same group of the periodic table as element A? So if you observe carefully that which element is similar to element A, we know that element A has about 3 electrons, and we know that there's 1 electron in its outermost shell. So, which element is similar to all the other elements specified here? So we know that element B and element A are pretty close to each other, or kind of close, but they're not very close. Now the reason is because element A has 2 shells, element B has 1 shell, and on top of that, we can see that element E also has something in characteristic with element A, since they have 1 electron in their outermost shell. So, which is similar to element A would be E, since they have 1 electron in their outermost shell. Okay? Alright, let's move on to the next question. Is that which element exists as single atoms? So exists as single atoms. That is kind of like element C, because it has a full outer shell of electrons. That is the reason why we're going to choose element C, is because it has a full outer shell of electrons. Let's move on. The next question states that there are two isotopes of element A. Information about the two isotopes is shown in the table below. We know the mass number of the isotope, we know the percentage abundance. Now this is more of a, let's say, a chemistry calculation. So you guys have to know this formula is that the relative atomic mass is equivalent to the sum of, in brackets, isotopic abundance times the isotope mass number divided by the sum of abundance of all the isotopes. All right, that's how you pronounce it. So we have to also give the answer to about 2 decimal places. So what we're going to do is that we're going to write that symbol down as well. So you have AR, where R is a small letter in that case, and you have the sum of the isotope abundance. So what you have to do is that instead of taking this as a percentage, you're going to take it as a individual number. So you're going to put in brackets 92.5. You're going to multiply it by the mass number of that isotope, and you're going to add it up, put the brackets again. You're going to multiply 7.5 times 7, put that in brackets. You're going to add these two values divided by the sum of abundance of all isotopes. If you put 92.5 plus 7.5, if you're equivalent to that, if you actually see that 92.5, if you add it up to 7.5, you get about 100. So this is about 100. So that's why you can divide by 100 as well. It's all right. So what we're going to do is we're going to put these values all together. I'm going to use the calculator, guys, since that is much more helpful. In this case, you're going to put it in brackets. Once you do that, you have 92.5, what's in, plus 7.5. It's going to give you a value of about 6.075. Since we have to give it to about 2 decimal places, what you're going to do is you're going to write AR is going to be equivalent to 2 decimal places. That's going to be 6.08. This is going to be an answer, and they have no units, so you're going to leave it as a number itself. So it's going to be 6.08. That is going to be our answer. Guys, remember, one tip is to remember this formula, and you guys have to understand how to use this as well. All you do is just multiply this together and add it with the multiplication of those two values. Divide it by 100, since the percentage abundance, they add up to 100. So you can divide by 100 as well. So 6.08 should be your answer. Let's move on to the next question. Now the next question, here we can see a nice little periodic table diagram. We know that there are 5 elements, V, W, X, Y, Z, and they are shown in the periodic table. The letters are not the chemical symbols of the 5 elements. So we have to use the correct letter, V, W, X, Y, Z, to answer, let's say, each of this question. So which element is a transition metal? We know that Y is a transition metal, since it appears to be in between group 2 and group 3, if you guys look closely. So it's going to be Y. Which element is in group 2? Group 2 is going to be roughly about here, so it's going to be W. That's going to be our answer. Which element is a noble gas? Like I said, noble gases are usually at the end of the periodic table here at group 0. So it's going to be V. V is going to be the noble gases. Then which element has the atomic proton number of 4? So we know, since it's 4, they should be roughly about somewhere of group. So which element has an atomic number of 4? So you have to carefully look which one has. If you guys look closely in the periodic table, is that I think the first letter W. Since it holds for beryllium, it's going to have an atomic number of 4, so it's going to be W. Alright, which element only forms 1 plus ions? That's going to be X. Since it has a group 1, it's going to be plus 1. Alright, so it's going to be X. Now this is going to be X in this case. It's a total of 5 marks, and that's how you solve it. Let's move on. There's a lot of tick questions. Again, now you can see a nice little diagram again. You can see that the diagram shows the chemical symbols of the 5 elements in the periodic table. You have to choose the correct chemical symbol to complete each sentence. Now the element that is an alkali metal is, of course, it's going to be sodium. So you're going to say Na. That's going to be you have to choose a symbol, so you have to write down the symbol. Now the element that is a transition metal, that's going to be Cu. It's going to be copper. Element which is a group 4, it's going to be carbon, C. Element which is having a full outer shell, that's going to be a halide gas. Not halide gas, sorry guys. It's going to be a noble gases, since it's basically this column here, since they have basically full outer shell of electrons. So it's going to be He. It's going to be about helium, right? So it's helium. That's going to be our answer. Now, which other element goes in the shaded box? So in this shaded box, it's usually is for hydrogen. So that's going to be H. So we're going to write H down. Let's move on to the next question. Alright, next question states that this question is about the periodic table of elements. Use a chemistry data sheet to help you answer these 7 questions. In 1869, Dmitry Mendeleev produced an early version of the periodic table and draw a ring around the correct answer to complete each sentence. Mendeleev first arranged the elements in order of their atomic weight. So you're going to circle that up. Mendeleev then placed the elements with similar properties in columns, also known as, they're called groups. So you're going to highlight that one. When the next element did not fit the pattern, Mendeleev he left a gap for these undiscovered elements, so that's why I'm going to highlight that as well. And then Mendeleev was not able to include the noble gases in the periodic table because the noble gases have not been discovered by until like 1869, so that's a reason. So you're going to highlight all of those points. Now you're going to use the correct word from the box to complete each sentence. In the modern periodic table, elements are arranged in order of their number of their protons. That's going to be your answer. And their nucleus elements in the same group have the same number of, let's say, electrons. That's going to be also your answer. In this case, sodium Na is in group 1 of the periodic table. Nickel Na is a transitional metal. 2 correct statements about sodium and nickel is that sodium and nickel are both metals. That is true. Sodium has a higher melting point than nickel. Sodium is more reactive than nickel. That is also true again. Since alkali metals are really more reactive than transitional metals are less reactive than alkali metals itself. Now, chlorine, bromine, and iodine are in group 7 of the periodic table. Chlorine is more reactive than bromine. Complete the worded equation. So since chlorine is more reactive than bromine, what it's going to form is sodium chloride, and that's true, and it's going to form bromine. So you're going to write down bromine since it's a worded equation. Now, why doesn't iodine not react with sodium bromide solution? Now, the reason is because iodine, if you look in the reactivity series, by the way, it's really important that you guys remember the reactivity series. You guys can Google it up if you need to check what's the reactivity series. Is that iodine is less reactive than bromine. That's going to be your answer for about 1 mark. All right, let's move on to the next question. Next question states that you can see again there's a lot of periodic table diagrams, so you can see that the letters are not the symbols. Which letter represents an alkali metal? We know group 1 metals are also known as alkali metals, so it's going to be A. Which one's a transitional element? We know that transitional elements lie around between group 2 and group 3, so it's going to be C. We know that what is a group 4 element? It's going to be roughly about A, since it's 1, 2, 3, 4. Group 4, that's going to be A, so it's 100% A. Now, a chemistry teacher demonstrated the reaction between sodium and water of a class of students. One of the students wrote the following notes: is that the reaction between sodium and water, this piece of sodium was cut off easily with smaller pieces of knife. You can see the sodium floated, melted, moved on the surface, it fizzed. Pretty close to what the properties are. Now, what's the evidence is that sodium has a low melting point. So the first evidence is that it quickly melts with water. So you can see that it melted quickly with to give a silvery ball. So it's going to say that sodium quickly. You can say that sodium quickly melted. That is going to be your evidence. Sodium is soft. It's stating that it's easily cut. It can be easily cut. Since you guys can see that that a piece of sodium was easily cut from the question itself, so you can say that sodium can be easily cut, that a gas was produced in the equation. A gas was produced. You can see that it fizzed, so there was like fizzing, so that could be your answer. Fizzing or bubbling or effervescence, those could also be your answer. So basically I got these answers from this question itself. It clearly stated that it melted, it fizzed, it was cut out easily. All right, let's move on to the next question. Now the next question is about lithium and sodium. We know that you have to use a chemistry data sheet to help you answer this type of questions. In which group of the periodic table are lithium and sodium? You know that lithium and sodium both lie in group 1. So you're going to check that periodic table there. They both lie in group 1. Now, lithium atom can be represented using this. What is the name of these particles, right, which have a positive charge? That is going to be your protons. the nucleus that have no charge, which is going to be your neutrons. That's going to be your neutrons, okay? Now, use the correct answer from the box to complete the sentence. Is that the mass number of this atom of lithium is, whether it's 3, 4, or 7, we know that the mass number of lithium is 7. The atomic number is 3, all right, of lithium. So for lithium, the relative atomic mass, or let's say the mass number, is 7. Let's move on to the next question. Now, the next question, you guys can see there's a diagram of sodium reacting with chlorine to produce sodium chloride. You're going to say that sodium atom changes into sodium ion. Because it's a metal, it loses when an atom, let's say, loses an electron, they become basically positive charge ions, are also known as cations. But when an atom gains electrons, they automatically become negatively charged ions, and they have kind of like a negative charge, and they are called anions in that case. So since sodium is giving out or losing electrons, it's becoming a sodium ion with a positive charge, so it technically becomes a cation. So basically, they are losing an electron. That's going to be the answer. Now, a sodium has, I think this question is supposed to be connected with this. So sodium has technically a positive charge, sodium ion. Now, the ions in sodium chloride are held together by strong electrostatic forces. That's going to be your answer, all right? They are held by strong electrostatic forces. Let's move on to the next question. Now, the next question states that sodium chloride is an ionic compound. You're going to take two properties of the ionic compounds. The ionic compounds, they really have high melting points, and they really have strong bonds. So these are going to be your answers. Let's move on to the next question. Now, you can see that there's a formula of sodium chloride, which is NaCl. You have to calculate the relative formula mass of sodium chloride. So since you know that this is sodium chloride, they've given you a relative atomic mass. What you're going to do is that you're going to add both these together. So you have 23 plus 35.5 to give you a value of about, let's say, 58.5, since there's only one atom per element. So you have 58.5 with no units. Now, the reason is because there is no units. It's just because it's a relative formula mass. Technically, there are no relatives. So it's going to be 58.5. Now we're going to draw a ring around. The correct answer is that the relative formula mass of a substance in grams is about 1 mole of a substance. You can use Avogadro's constant as well. Now, now this is coming under nanoparticles topic, is that nanoparticles of sodium chloride are used to flavor crisps. What are nanoparticles? Nanoparticles, you can mention that nanoparticles are very small particles of about, let's say, 1 nanometer, 1 to about 100 nanometers in size. Or you can mention that there are about a few hundred atoms. So the points that you can mention is that nanoparticles are very small particles, or that nanoparticles are having a size of about 1 to 100 nanometers in size, or nanoparticles are particles with a few hundred atoms. That's something that you guys can mention there as well. Let's move on to the next question. The next question is using the chemistry data sheet to fill out these sentences. So the elements in the periodic table are arranged in the order of their atomic number. Everybody knows that. The elements in group that are called noble gases. Now, when you're doing this type of questions, preferably don't write the number 8. Just write group 0. So the group 0 are called the noble gases. The value 8 is also allowed, but in terms of being safe, you can write group 0. Calcium is in group 2. Name one element, another element in group 2. So you can use your chemistry data sheet or the periodic table. In group 2, you can see that there is magnesium as well. So you're going to write magnesium down for that mark. You can mention beryllium, strontium, barium, or radium. It's also fine as well. Draw a ring around the correct answer to complete each sentence. So that sodium is, we know it's in group 1. So it's an alkali metal. All group 1 metals are called alkali metals. We know that nickel is a transition metal since it appears between group 2 and group 3. That's why it is a transition metal. All right, let's move on to the next question. Why did Mendeleev leave gaps in his periodic table? Like I said, it's for undiscovered elements. Gaps were left. You can say that gaps were left for undiscovered elements. All right. Undiscovered elements. Or you could say that they were basically for undiscovered elements as well. You can mention that they are 4 elements with similar properties that were in the same groups. You could say that maybe because the elements fitted the pattern of the properties, that could also be your answer in this case, all right? But basically, you can just say that the gaps were left for undiscovered elements. That's going to be your answer. All right, let's move on to the next question. Next question, you can see Mendeleev there, is that you can see Mendeleev arranged the elements in the table. You have to draw around the correct answer to complete the sentence, is that in the periodic table, the columns are also known as, like I said, they're also known as the groups, all right? So just one reason why hydrogen should not have been put in column 1. Now, because hydrogen should not be put in column 1 is because it is a non-metal. Hydrogen is a non-metal. That's why it cannot be in group 1. So that's why, like I said, at the first question, it was, if you guys have mentioned that I've checked between element A, element B, or element E, I chose it between element A and element E in the first question. So this is, in this case, hydrogen is a non-metal, so that's why it cannot be placed in group 1 or column 1, all right? Now, where has a new family of elements been placed in the modern periodic table? It's basically placed for a new element, which is called helium. These were placed to the right of column or 7 or group 7, to the right of, let's say, to the right of group 7. That's what you're going to mention. That's why group 7, that's why they're called group 0 elements, okay? Or in group 8, they're also known as the noble gases, but you're not going to mention that in this case. You're going to say where have they been placed. So that's why we're writing to the right of group 7. So mention this, okay? Now, complete the sentence. In the periodic table on your data sheet, the elements are arranged in order of their atomic number. That's going to be for about 4 marks. All right, now let's move on to the next question, is that how a metal used depends on its properties. You can see the properties of sodium. You can see the properties of iron. Sodium compared with iron is that, take 2 properties of sodium compared with iron that are shown by the students' observations. You can say that sodium has a lower density. Okay, so basically it's floating on the surface of water. So sodium has a lower density. You can mention that. Sodium is more reactive. Now, this is because it reacted to produce a gas that there was no sodium left after 5 minutes. Whereas iron, you can see it did not react, it did not melt. So whereas sodium melted to form a molten ball of sodium, so that's why sodium is more reactive than iron. So that's why we're ticking the 2 points that sodium has a lower density. Oh wait, actually, sorry guys, I've ticked sodium has a higher boiling point. It actually should be sodium has a lower density. That is because it floats on the surface of water. So you're going to say that sodium has a lower density and that sodium is more reactive. All right, let's move on to the next question. Is that you have to draw a ring around. The correct answer is that sodium plus water is equivalent to sodium hydroxide plus it's going to be hydrogen. All right, any metal plus water will always become metal hydroxide and hydrogen. That's kind of like a formula rule that you guys can use there. Now, sodium hydroxide is an alkali because because it produces OH hydroxide ions in an aqueous solution. So that's why it is an alkali. Now, this seems to be the end of all the questions. If you guys have enjoyed the video, please do like, share, and subscribe to our channel. It really helps a lot. And do comment below on what your thoughts are about this video and whether I should continue solving questions related to past papers or for topic questions. And yeah, I think time codes are in the description box below, so you guys can skip to any questions you guys like. And I think that's it, guys. All right, bye guys.